Hello class, today we're going to cover Chapter 7, Section 3, Similar Triangles. Our objectives today are to identify similar triangles using the AA similarity postulate and the SSS and the SAS similarity theorems, and to use similar triangles to solve problems. Now, SSS and SAS should look familiar because we use that to solve to show congruent triangles. All right, so let's start with our angle-angle similarity. If two angles of one triangle are congruent to two angles of another triangle, then these two triangles are similar. Remember that if we know that two of them are congruent, we can prove that the third one is congruent. And to be a similar figure from our similar polygons, you need to have congruent angles and proportional sides. So if angle A is congruent to angle F, and angle B is congruent to angle G, we know that angle C is going to be congruent to angle H. So therefore, triangle ABC is congruent to FGH. So let's put that to use here for problems 1. Determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. Hint, our reasoning should be easy because we only have one angle similarity statement. All right, so looking at our first one, we see that two angles into both the triangles, and we can find the third one by taking our 180 and minusing the third one out. So we get 75 here, and right away I can see that these two angles and these two angles are congruent. So I can say angle or triangle LJK is similar to triangle MQP by our angle similarity. All right, looking at B, I see I have some parallel lines, and I also notice that my two triangles meet at S. So we have some vertical angles, and with our parallel lines, we have some transversals that cut through that show us some more congruent angles and some congruent angles here. So now we have at least two of them that are congruent. So go ahead, I want you guys to write my similarity statement and then my reasoning for me to have that done for tomorrow. All right, now let's talk about side similarity. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. Okay, so we are going to look at our proportions this time, not looking for congruent sides. So if I have JL, and that's proportional to MQ, now remember we want to match these up from one triangle to the other, and that is proportional to my MP and proportional to my LK and QP. If I can say that all three of those are proportional, then I can say that my triangles, JLK and MQP, are similar. All right, so let's go ahead and look at the next page. Determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. Now, looking at this diagram, I really don't have any congruent angles or that I can base which direction to go from. And so we're going to have to try things a couple ways. And so right away, I can see that I know that A to B and D to E are going to be similar because they are both the bases. So I know I can say 9/6, but now to come up with my other two proportions, we need to figure out, are these two sides proportional and these two? Or are the ones across from them the proportional ones? So I'm going to set up the red ones and then set up the blue ones, and then I'm going to ask you guys to find the scale factor with those. So I'm going to have 6/4. Oh, and we don't know if these are equal, so we're going to put in those question marks. And 7.5 to 5. All right, so go ahead and make those into some decimals and see if they are equal. And then let's go ahead and do it with the blue ones, and then find those into decimals. So I know my 9/6 is going to still be true, but we want to know, is that proportional to 6/5 and proportional to 7.5/4? If it works with one of them, then we know our two triangles are similar. All right, now let's talk about side angle side similarity. If the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, then the included and the included angles are congruent, then the triangles are similar. So this is just like when we were talking about it in congruent triangles. The included angle is the one in between the two sides that we're talking about. Okay, except for here, the sides aren't congruent. The sides need to be proportional. So SR is proportional with XY. And if that goes with our ST and YZ, and our angle S and angle Y are congruent, then we also can tell from here that this third side is going to be proportional. And that's coming from our SAS congruence theorem. Because we know if our sides and our other sides and our angles are going to be congruent, we can say that that third side is going to have the same proportion for that. So RST and XYZ are going to be similar triangles. All right, so looking at number 3 here, determine whether the triangles are similar. If so, write the similarity statement and explain your reasoning. So very similar to what we've already been doing. So I know that my angles, included angles, are going to be congruent. So I can say W is congruent to angle W. That's a given. Okay. So now I'm going to just match up my sides 10. And here, this one's a pretty obvious one. 10 is going to go with the 20 because that's going to be nice, because 11 and 22, if we do both of those, they are both 0.5. So that one I didn't need to try both ways, just because it was a very obvious, the numbers were very straightforward. So my two sides are proportional and my included angle is proportional. So I can say triangle TWZ is similar to triangle YWX by side angle side. All right, I want you guys to try B out on your own. And you're going to be using this small triangle here. And then you're going to be using the large triangle. And you're going to be comparing those. And so here we know that this entire side is 25. And this entire side here is going to be 30. And you're going to compare that to those angles in there. Or, I mean, those sides in there. And you do know that the included angle is congruent because it is within both of them. So go ahead and try out B for tomorrow. All right, in the figure, angle ADB is a right angle, which is marked. Which of the following would not be sufficient to prove that triangle ADB is congruent or is similar to triangle CDB? This one we're going to have some discussion on tomorrow when you come to class. So think about it, try them out, see what you think. All right, number 5. Given that RS is parallel to UT, find RQ and QT. So first we need to find our X, and so we know that these are parallel, so I can say that my included angle is going to be congruent, so that we have our side angle side. So I'm going to match my 4 with my 10, excuse me, and then my X plus 3 goes on top because it came from the same triangle as the 4, and then I have 2x plus 10 on the bottom. If we do some cross multiplication, we get 10 times x plus 3 is equal to 4 times 2x plus 10. Distribute that, 10x plus 30 equals 8x plus 40. We move some terms around and we get x equals 5. Now don't forget, your question actually asked you to find QR, or RQ and QT. So I'm going to just plug that 5 back in there and plug that 5 in back there. So I know that my RQ is going to be 8 and my QT is going to be 20 with that one. All right. And our last problem, given AB is parallel to DE, find the length of the lake. So you're going to find this X here. And we know that those are parallel, so I know that those are going to be our included angle congruent. So I want you guys to set that one up and come with that done for tomorrow, and we'll see you guys then.